Okay, is my screen visible?
Yes, sir.
Okay. Okay, in the last class, we are discussing about the parts of the piston, and we have discussed about piston ring, piston skirt, piston pin, and the piston bearings. And we have one more part left, that is the piston head or the crown. Okay, piston head and or the crown. It is called as piston head or the piston crown. So it is nothing but the topmost part of the piston head, or it's called the crown. Okay, it is the piston crown or dome, the head of the piston. This is its top surface. It is the part that comes into contact with the combustion gases. So once the explosion inside the cylinder occurs, the heat energy or the explosive energy is first transferred to the piston head. Okay, wherein the force is then transmitted to the connecting rod. So the first force is on the piston crown or the piston head. As a result, it gets heated to extremely high temperatures. So it is in direct contact with the combustion products. So once combustion occurs, the temperature inside the cylinder rises to about 200 degrees Celsius, and in that temperatures, the piston must be able to withstand such temperatures and pressures. For that purpose, piston head parts are made up of special alloys, among them steel alloy. So steel is one of the most tensile and compressively strengthened material, and it will be able to withstand high temperatures and also pressures generated inside the cylinder. Then the piston head is usually built with channels or cavities. So you can see what is a channel or cavity. So there is a cavity here. So it is not in only flat head pistons. There is the surface will be plain. Okay. In other cases, small cavities like this, or before we have seen many shapes, dome shaped, and all we have seen. So in that conditions, there are different holes or different cavities provided inside the piston head. So the purpose of this is to create swirl. Okay, what is swirl? I will show you. And different piston head types are used in different engines. That is different cavities etc are provided. So these are some of the cavities shown. So this is a dome type piston. So it is in the shape of a dome, and you can see there is a cavity here. In the same way, there is a cavity here also, and here you can also see there is a cavity here, then another cavity. See, so this is for the valve. So there is a valve present inside the engine, and this is the valve. These two things are the valve. This is called the inlet valve, where the air or the fuel is injected into the cylinder. Then this is the exhaust valve through which the exhaust products are emitted outside of the combustion chamber. Okay, so in some pistons, some areas are removed for the valve to seat. So the piston is moving upwards and downwards, so it moves particular motion upwards, and due to that, the valve will be coming into contact with the piston. So to reduce the damage on the valves, such recesses are formed. So this is called a recess. And another importance of this cavity is that, so when I told you there is a clearance volume, so there is a this if this is the top of the engine or the engine head, the piston can only come up to this point. I told you that, and there is a small clearance here. So when the clearance volume is lower, suppose if this is a flat piston, and when you compress the fuel air mixture, once it gets compressed, the compressed fuel will exert a heavy pressure onto the piston. Okay. And due to that, maybe due to the insufficient tensile strength of the piston, it may fracture or it may get melted. So such and such can happen. So to avoid that and to provide more surface area, if you produce a cavity inside the piston head, the fuel or the compressed fuel air mixture can pass into the cavity. So these are also another types of cavities shown here. Then here is another type wherein we are giving only a recess area, and this is also the space given. This is a flat type piston wherein the recess area is provided. Okay. Now, what is swirl? Okay, swirl is shown here. So the purpose of swirl is nothing but to mix the air and fuel molecules. So why do you have to mix? So when we are giving combustion, it is not the fuel that is ignited. It is the fuel that is ignited, but not the air. So sufficient amount of air must be in contact with the fuel to burn it completely. So you have to get more heat energy. So to get more heat energy, all the fuel particles must come into contact with the air. Okay, so when there is insufficient air or fuel is not having, the fuel particles are not having much air, to air means oxygen. So oxygen is present in the air. So we are providing air into the cylinder, and that air contains oxygen. So in turn, the fuel burns when we give spark. Okay, and if there is insufficient air present inside the cylinder, smoky exhaust, or we will smell the fuel outside in the exhaust outlet. So you know we have taxi auto rickshaws, and in auto rickshaws we when we go behind them or when we are driving behind them, we can smell their exhaust products. So while smelling it, you will smell a small hint of petrol itself inside the exhaust products. So this is because of insufficient air. Okay, and due to another process, because of a two-stroke engine, both cases, but insufficient air is also a factor, and due to that, combustion does not takes place. Okay, so if you mix the fuel well with the air, the fuel can ignite and combust more efficiently. For that purpose, we are providing this chamber. In such a way, the chamber is designed. So what happens means, when the piston moves from bottom to upward direction, that is from BDC to TDC, the fuel and air will pass in such motion. See, when we are moving upwards, the fuel moves downwards, and due to this shape, the fuel and air particles move like this. There is a swirl motion. There is a swirling. Okay. Due to this mixing, the air fuel or the air fuel particles gets mixed well together. That is swirling motion. Then functions of the piston crown. So what is the function of a piston crown? First function is the creating of swirl to make combustion uniform and regulate knocking. Okay, knocking is another procedure. We are studying it later. At that time, I will discuss. And the main purpose is creating swirl to make combustion uniform. Okay. So we have seen what that swirl is. It is creating a homogeneous mixture. Next is act as a heat barrier between combustion chamber and lower piston parts. So what are the lower piston parts? The piston pin, the piston crown, piston rings, the piston grooves. Then comes the bearing underneath the piston, also the small end of the connecting rod. So they act as a heat barrier. So the major heat will be on top of the piston crown, while the others will be lesser. In some pistons, you can see the piston are made of parts or two materials. The piston crown will be made of one heavy material that will be able to withstand, such as stainless steel, alloy steel, that can withstand heavy temperatures. But on the piston skirt and all, different materials such as alloy of cast iron or alloy of aluminum are provided. So the basic contact comes, basic contact of high temperatures will be in contact with the piston crown. So the piston crown is the only thing that will be given much temperature resistant material. Next function is the containing the pressures resulting from the knock in the cylinder. So basic pressures, the high pressure we obtain during the explosion or the combustion stroke. During that time, the pressures will reach very high pressures, and the piston crown must be able to withstand such pressures. Next is the, so we have discussed about piston bearings. Next we are moving on to another component. So after the piston comes the component inside the engine block, that is the connecting rod. So this is the shape of a connecting rod. So basic function of a connecting rod is nothing but the piston moves in a linear motion. Okay, or it is called the reciprocating motion. So what is the reciprocating motion? Once it starts from one point, it goes to another point and then returns to its previous position. That is called a reciprocating motion. Okay, so in a reciprocating motion, the piston moves upwards and downwards continuously, and the connecting rod converts this up and down motion into a rotation of crankshaft or the rotary motion at this end. Okay, that is what the purpose of a connecting rod is. So on looking at the figure, you can see there are two parts of the connecting rod. This is called the small end of the connecting rod, which is connected to the piston by means of a wrist pin or a piston pin. By means of a wrist pin or a piston pin. Then the small end, the big end is connected to the crankshaft. The big end is connected to the crankshaft. So I have discussed before about piston bearings. So these are the bearings provided at the small end. So this is the small end of the connecting rod, and the bearings, these bearings are provided at the small end. And see, you can see here that at the big end also there are sufficient bearings. So providing these bearings means the thing that will be weared out first will be the bearings. Then after only the connecting rod will be used. So we once for servicing of the engine, mainly the bearings are replaced. So the bearings have sufficient working time or a sufficient life. After that, it will be weared out from this position. So before that, we have to change it so that it will not affect the big end or the small end of the connecting rod or in any part. Even in pistons, even in cranks, there are bearings. So many bearings are provided, and bearings should be replaced so as not to damage the machine component. So once the machine component gets damaged, we have to replace the machine component, as it will not have sufficient strength than the previous state. So it has to be replaced. So for that, bearings has to be replaced before its wearing out is over. So at the big end, you can see the bearing is in this shape. So there is a small groove or a slot provided for sitting inside the big end. While in small end, it will not have any grooves, but it will sit perfectly inside. Okay. So at the big end, why the connecting rod is built as a small end and a big end? So the piston, once it receives the power stroke, it is thrown downwards. So during the power stroke, the fuel air mixture explodes and it throws the piston downwards. And this force is so much, the pressure is very heavy, and this pressure is so much that the piston is thrown downwards and the force resulting to that is very high. So the force that is occurred at the piston transfers to the the connecting rod, and thereby to the crankshaft. Okay, due to that high force, this big end must not have any failure. So the maximum force will be occurring here at this end. So the connecting rod must not fail under this working condition. So providing a big end will result in the longer life of the connecting rod. That is why a big end and a small end is provided in the connecting rod. Then the connecting rod is made up of forged steel. Also, aluminum alloys are used. So, steel and aluminum alloys, steel has better tensile strength or strength in terms of aluminum alloy. And also, aluminum and steel can both conduct heat outside very fastly. Okay. So, this is why forged steel and aluminum alloys are used for connecting rod material. Then, so you can see here also the bearing that is seated inside the connecting rod, big end, connecting rod, big end. Also, holes are provided in the bearings so that oil can flow easily through the bearings and the big end. Then connecting rod also is made by cast steel or fabricated steel. Then nodular steel or aluminum alloy. These are the materials used for the construction of connecting rod. Then some parts of the connecting rod, we have discussed about the small end and the big end. Then there is something called as a bushing. So bushing is nothing but the bearings are provided inside the small end of the small end of the connecting rod. Then bearing inserts are these points. So these are connecting bearing inserts provide sufficient seating of the bearing inside the connecting rod. Then bolt and nut, you can see here, there is a bolt and nut provided here. Then shank. So shank is not shown here. We don't have to study about that. Then wrist pin. There is a gudgeon pin that is shown here. Then piston that will be mounted on top of the small end. Then bearing cap. The bearing cap is this one. This part is the bearing cap. This is fitted inside the bigger end for holding the bearing. So the bearing cap is here. In this case, it's here. And then it is bolted down. So once we are disassembling that, we will be removing this bolt, then removing the bearing. Then the next part is the crankshaft. So from the connecting rod, it comes to the crankshaft. So you can see here the piston, the connecting rod, and then this is the crankshaft. Okay, this is the crankshaft. So what is the purpose of the crankshaft? So once the reciprocating motion of piston is converted by the connecting rod into rotational motion, and this rotational motion is transferred to the crankshaft. So the rotational motion occurs in the crankshaft. So that is the purpose of a crankshaft. So the mechanical rotational power is obtained in the crankshaft, which will be then transmitted to the wheels. So it is connected. The connecting rod big end is connected to the crankshaft. So there are here you can see there are four pistons, and there will be 4 connecting rods and 4 points for each big end to be connected. So we'll be seeing what is the parts of the crankshaft. So you can see the functioning of an engine here and how the crankshaft is moving. Okay. Then during one stroke, the center to center distance between the crank pin and the crankshaft is half of the piston displacement. So what it means is the piston moves during the first stroke, that is the suction stroke, the piston moves from top to bottom, from the TDC to BDC. During that motion, the connecting rod moves from this point till this point. Okay. maybe it will be here because the figure is shown like this. So it may be here. So from here to here it moves. So that will be half rotation of the crankshaft. One movement of the piston provides half movement of the piston. Okay. Then when the piston moves again topwards, see it moves upwards. So when it moves upwards, the rest of the motion occurs like this. So another half. So what is it saying? One stroke, that is one stroke. What is a stroke? Stroke is nothing but the movement of piston from TDC to BDC or from BDC to TDC. That is from up to bottom or from bottom to top. One movement of that, any one, is known as stroke. So one stroke is half the crankshaft movement, half the movement. So for one full revolution, the piston has to travel or two strokes must be completed for one full revolution of the crankshaft. Two strokes should be done for one full revolution of the crankshaft. Thus, one complete revolution of the crankshaft makes two strokes of piston. That is what is explained here. Then materials and the manufacturing of crankshaft. The crankshaft should have adequate strength, toughness, hardness, and high fatigue strength. So the complete force from the big end of the connecting rod will be provided on the crankshaft. So the crankshaft is made up of a heavier material, that it has strength, toughness, hardness, and a high fatigue strength. Commonly used crankshaft are cast iron crankshaft due to its high toughness and strength. Also, low alloy carbon steels are done. The procedures for the manufacture of crankshaft are forging and casting. So in forging, we use a tool and we are forging the crankshaft into shape. This is the forging procedure of the crankshaft. And most commonly used procedure is the casting procedure, wherein cast iron is melted and it will be poured into this die. This is a die, and this die will be placed here, and molten cast iron will be formed here. Molten iron is poured into this die, and once it cools down, we will get a cast iron crankshaft. Okay, these are the two manufacturing processes involving the production of crankshafts. Then parts of the crankshaft. So these are some important parts of the crankshaft. So the first one is the crank pin. So you can see here. So crank pins are nothing but the points at which the big end of the connecting rod are connected. Those points are called as crank pin, or it is also known as connecting rod journals. We'll be studying about it later. So here this is a 4-piston engine or a 4-cylinder engine wherein 4 pistons are present. So there will be 4 crank pins on the crankshaft. If it is a 6-cylinder engine, there will be 6 crank pins. 8-cylinder, 8 crank pins. 12-cylinder, 12 crank pins. So it all depends upon the number of the cylinder. Okay. So crank pins are the points shown here. So since it is a 4-cylinder engine, 1, 2, 3, and 4. 4 crank pins are provided. Next are the main journals. So what are the main journals? After the crank pins, you can see there is one point here, then there is a point here, and there is a point here. Okay. These are known as the main bearing journals. So you can see here, 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 and here. Okay, center and 2 sides. So what is the purpose of the main journals? The main journals is responsible for holding the crankshaft inside the engine block. So due to the rotational motion, the crankshaft can move this way. If we are not providing any journals, the crankshaft can move uncontrollably. We can't control it, and so much vibration will be there. To hold the crankshaft in position, main bearing journals or main journals are provided. So it will be seated perfectly in the engine block. That is the purpose of main journals. Then comes crank webs. Crank webs are nothing but uh, the portions in between a crank pin. So this plates in between crank pin. So this is one crank web. This is another crank web. Then we have counterweights. So this is a counterweight, and here also we will be providing a counterweight. So counterweights are added so that the weight of the crankshaft here and also here will be balanced. So the weight throughout the crankshaft will be balanced. So first the crank pins are formed, and then crank pin and main journals are formed, and then counterweight is added to balance the weight of the crankshaft at both ends. Or the problem occurs when one side there is a more weight, this side will be tilted more than the other side. So that does not happen. It must be uniform throughout. For that, counterweights are added. Then comes thrust washers. So it's not shown here. Washers are nothing but for perfect seating and also reducing the movement of the crank. Thrust washers are provided. Then comes oil passage and oil seal. So you can see how the oil passage, there are holes here. See, there are holes in the crankshaft. So providing holes, and the holes are machined like this. So if there is a crank pin here, there is a hole here, and on the crank pin we will be connecting the bearing and the connecting rod big end. Okay, and those also has holes inside them. So oil is completely transferring inside the crank pin and also the crankshaft. So like this, there is oil passages inside the crankshaft. So oil passages are shown in the dotted lines. So holes are also provided, and we can see it here, but that is why I provided this figure where you can see the passage. Next comes a flywheel. So flywheel I'll discuss it. Another part is the crank pin. So what was the crank pin? The crank pin is the place where the piston, the connecting rod big end is connected. So we can see here these hold portions are the crank pins, the others are the main journals, and at the crank pin you can see the hole is provided in a slanting motion. You can see in here also it is provided in a slanting or an inclined passage. So this is a crank pin, and the crank pin allows for the firm attachment of a connecting rod to the crankshaft. That is the main purpose of the crank pin. Then comes the flywheel. So what is a flywheel? Flywheel is nothing but a wheel that is provided in the crankshaft, wherein this then transfers the power from the flywheel to the clutch, then to the gearbox, then to the propeller, then to the wheels. So flywheel is then attached to the clutch. So flywheel is provided for the engagement and disengagement of a clutch to the engine. That is why a flywheel is used. Also, there is another purpose which I will be discussing later. So what we'll see the definition. A flywheel is a fairly heavy steel wheel that is attached to the rear end of the crankshaft. So it is attached to one side of the crankshaft. Then the size of the flywheel is dependent upon the number of cylinders and the construction of the engine. So more number of cylinders means higher, bigger size of flywheel. Flywheels are made up of cast iron flywheels, which are used in older steam locomotives. Then in car engines, it is used as cast or nodular iron, steel, or aluminiums were used. And also high strength steel flywheels are also used in larger engines. A common example of a flywheel is, so you can see the old steam powered flywheel. This is a big flywheel, and the connecting rod is connected. There is a connecting or a link between this that you don't have to look. This is the flywheel. Then another common example is during sewing machine. The tailoring, in the tailoring shop, you can see a sewing machine. This is the flywheel. So what is the important feature of the flywheel is that when we press this pedal in a sewing machine, when we press this pedal, if we press it one time, we will be providing force to the flywheel and the needle turns and this equipment works. Then if you remove that force, one pedal we give for we will be exerting force there, and then we remove that force, that is our leg, and when we remove that force, you can see that the flywheel rotates and brings the pedal back to its original position. That is the important feature of a flywheel. So what is it doing? When we exert force, the flywheel rotates, half rotation will be done, and it will store that force exerted into potential energy. So when we remove that force, the flywheel again rotates and brings the pedal back into its final position. That is half rotation. Again, it will be doing on its own. Okay, that is how it works. So, in the same way, in an engine also, flywheel provides such a potential energy. So, the only time we get energy from the engine is during the explosion or the power stroke. So we will get a heat energy and it is converted into mechanical energy, and that energy is stored in the flywheel. That energy is stored in the flywheel. So for the other strokes, then comes the next strokes. For the other three strokes, engine itself provides power for the movement of the piston. So this is happening very fast. So the potential energy is stored and then the flywheel again rotates, and during that rotation again the next stroke, that is exhaust stroke, takes place. Then again the flywheel rotates and suction stroke takes place, then compression after power. So again in the fourth stroke only next power is obtained. So for this is the cycle inside the engine. For that purpose only, we can notice that when we stop a vehicle and we are trying to turn the engine off without changing the gear. So when it is in the first gear, and you just, when the vehicle is at a rest and you raise the clutch from the vehicle tries to jump forward. So this is the reason. The reason is that the engine is still trying to work inside. Okay, due to the stored energy. So you are cutting off the engine gets off, and still the engine tries to move a little forward because there is this continuous motion inside the engine. So it will not stop immediately, but it will stop once the energy from the flywheel is expended. So this is the purpose of the flywheel inside the engine. Okay, I will wind up today's class. Next, I will take the attendance.